and he's enthusiastic and dynamic academician. Now he's going to speak on the topic AI to Sai. Sairam.
I have already bribed Praveen to give me 5 more minutes. It's very difficult to talk of AI and ML when you have hunger pangs. AI is not absolutely insane and ML is not mother-in-law. And I have my slides on the screen. So why is a doctor here talking about AI and ML? I'm not from the DMAX department. I learned my AI and ML because I thought there was a need to learn AI and ML. And I wanted to present this in a real world conference that Swami has given us a stage with, because we need to talk about this subject. Not in terms of a clinical reality, but in terms of how we look at research in India. That's why I called it From AI to SAI. We have a lot of honest research. This is Sathya Sai organization. We need to talk about the truth. We read books from the West and we make our own assumptions. We are a different breed. Southeast Asians are a different breed. We die young. We have different risk factors. But all my textbooks are all from American authors. When are we going to have our research? Unless we have collaborations with them, we learn how they do and then apply it to us. That last part gets actually ruled out. Do they all mean the same? This is all verbose. And I don't want to actually bore you at 1 o'clock in the afternoon with this. But then ML is a larger part of what is called as AI. And then you also have machine learning. You've got deep learning. So all of this tell us what? Are we really crystal ball gazing? Whenever I start talking about this in conferences, and not too many doctors do, everybody says, are you crystal ball gazing into the future? Are you telling us what's going to happen? Are you going to be really giving us predictive models? Yes, because they've been derived from Sathya Sai hospitals here and in our hospital in Whitefield. And they will be speaking the truth. Just for a point to be made here, and I always keep talking about this with like HK Chopra sir being here, we always have risk models that we create. Who is going to die, right? What do we use? We use a thing in statistics called regression. We see all those who have died. We go back and say, oh, these are the risk predictors. We say that when a patient gets a heart attack today, what is his risk of dying after 1 year? Are you saying that your treatment has no sort of benefit at all? No, what we are using is what is called as jackknifing. We try to project. That's wrong. That's where ML comes in. Because when you have too many variables, you can be hypertensive also, you can be diabetic also, you can be young also, you can have a family history also. How do they interact? So even when you do a propensity analysis with a multivariate analysis on regression, you can at the best say 70% of times that you're right. How does ML help? This is not about teaching anybody ML here. I learned it, but then I'll tell you how we actually apply it. Since we are short of time, I'll actually come to only the models. We never think about the third human concept, the time concept. We know the variable, we know the risk, we do not know how it can change in time linearly. That's what ML tells us. We got his award paper. I just show you 4 award papers that we have got. It's not trying to pat myself or our hospital on the back. I need you to see this. We have a disease called HOCM, where the heart becomes very thick. And we are always told that these people can die young, and they do. This is a very mortal disease. This is the first scoring system which was created for India. This is an American system. There's a Western data. There's a Japanese system. What about Bharat? We don't have that. So we had a flow chart. We saw all those who died. All those who survived, created a heat map. My friends from DMAX can actually know this. But in any case, it's about trying to look at the intervariability. And we found that if the Western data says MRI shows more than 15% fibrosis is going to die, Indians die at 10. If they say that LV strain is 15%, we die at 12. We are a different breed. This needs to be applied to us. And how did we do it? This is all the Python charts, the cluster plots. It doesn't matter. What matters is the score, and what matters is the accuracy, is that it's 85% accurate. You can almost tell who's going to lose his life, and that's important. More than that, 23% of first-degree relatives who never knew that they had HCM were actually picked up. You can save these lives. This is where mortality benefit comes in. This is not given in the Western books because this applies to our patients. Let's see a few more scores. We know that, and I have like Nilayam madam here, we all know we get congenital heart disease surgeries done at 14, 15, 20 years of age. In the West, it is 3, 4, 5 years of age because they're picked up so early. How does it change for us? Because we get operated late, our children, our young adults die. This is a paper which was talking about RV to PA coupling. Suffices to say that how the heart and the lungs are actually coupled with each other. And when we saw that, we actually derived a new model using machine learning. Again, I'm not going to bore you with statistics, but the idea is that it gives us a risk model, and this is what we started off with. Today, we have validated it. This is again the first in India and probably the first in the world. So we have validated it, given to our surgeons. My wife is a cardiac anesthetist. She knows how to start better so that she can get a better result. Because this is Indian data. There is no such data from the West which we can apply. Again, the statistical model accuracy is phenomenal. ML is not about talking hot stuff. It's about trying to look back. Research is really searching within yourself. Swami said, see always inside. This is what it is. We never saw within ourselves. We just applied data from the West. It doesn't work. Another award paper, just last year, we have this disease called mitral stenosis. Okay, rheumatic heart disease. Dr. Jagat sir is actually doyen in this. He's written books on rheumatic heart disease. And when it sort of goes for a longer time, the valve gets stenosed. So we use a balloon and we open it. This is the first paper which tells us anywhere in the world that this, how it applies to us, what is the chance of success. On that day, should I alert my surgeon to say, yes, this patient might go bad and I might need a surgical backup? No such paper has been done because this is a study on Indians. This is, again, I'm saying, not to pat yourself on the back, but the kind of predictors that we get on our lasso regression when we have done is completely different from what our Western books tell us. So when we apply it, we actually validate it forward. We see that the accuracy is tremendous. So we know whether we are getting into difficulty, into trouble in the cath lab. This is how we actually apply it. Again, all of this is done by machine learning. We see all the intervariable analysis, how each variate will work with another. So the number of combinations is amazing. I get more than 2 lakh combinations when I work on Python. So I know exactly this and this and this. Okay, this is not there. You have a diabetic patient and this, but you do not have young age. It's like that. So you have to see it in terms of multivariate analysis. And you can actually give precision medicine for a patient, which I think Vidya speaks about after me immediately. So this is how what gets you to the precision medicine. For this patient, what is the risk? Not for a population, not for a cohort. This is the composite base score, which was the balloon success evaluation score. Again, the first in literature. Validated, scored, accurate more than 87% of the times. So my surgeon is ready. He's ready in the OT saying, okay, if this guy goes bad, I know what to do. Another award paper. This is not again to show about awards. It's just that this is something that woke people up. Again, in the same HCM analysis, we actually directed something called as an electromechanical window. It's a simple thing which we do in echocardiography. It can be done by the bedside. It tells us the actual risk of dying. How accurately? How accurately does it tell? Let me tell you. We actually created this score again. It's not about just creating numbers and score. These are validated. So when we went ahead and validated them, I've given you 5 more. I actually bribed you, Praveen. So I have, no, I'll just finish in 2 minutes. The point is when we go for a hyperplane, it's called as a hyperplane on a support vector model. I just need 3 or 4 factors and I can tell if this patient has these, there is more than 90% of times that is going to die. And again, this is HCM, which is a mortal disease. So we plan in our department, we plan to put an ICD because we have to ration. We have to ration in our hospitals because we do not have too much of, free availability has to go to the correct person. So this is how we ration our like all our resources. The last paper would be about who dies after a heart attack. So we have gone back and done, this was something that Dasar had actually encouraged me to do long back, 10 years back, because we were seeing a lot of young people die young. I mean, die after a heart attack, even with an angioplasty, even with a successful angioplasty. So exactly why does it happen? So we went back, saw all the variables, saw the intervariable analysis, and then we found out that one of the most important things was late referral. Because we used to get patients 12 hours, 16 hours, 1 day later. And when we do an angioplasty, quote unquote, it's successful. but 3-4 days after that, then the patient dies. So you can explain a lot of things outside of just doing a regression analysis by actually using machine learning. I'll end up, because I don't want to take too much time, I just suffices to say that many of these models are actually very, very accurate. They have been derived from research on Indian patients. They apply to Indian patients. Let's have research in India for Indians. We cannot depend on the left, or like on the West. In-hospital mortality, 6th-month mortality, 12th-month mortality, all of this is accurate, because if you see any other score in literature, we have the Cadillac, we have the SLED-P, we have got the PAMI score, it's better than any score. So my take home is, no victory is without hurdles. If you are on a hurdle track and you do not get hurdles, you're not running the race. Simple. So we all need to do a SWOT analysis. What is the SWOT analysis? Our strengths is that we need research in India. Our weakness is that we cannot do research in India. So let's give more grants. We need more grants for research in India, because what is the data that applies to us ethnically. Western data cannot be extrapolated to us. Opportunities, millions, because we have a lot of fertile population that we can work on. And the theme of the whole thing is, can we prevent? Yes, we can prevent deaths. And prevention of mortality is a very, very strong, moniker in any part of medicine where you can prevent someone from dying. Threats, none. We have him with us. There are no threats. Just that we need more multicentric studies. We will give all of these so-called patented models, which have been patented in our hospital. We are going to give it to the Global Council. I need it to be used. I want it to be used across the world. Of course, it applies to us, but I'm sure Chandramani sir is also here. SEA is a different population. Southeast Asians die young. We need to know why. And these could help us potentially in knowing, because ML should not be relegated to just a department of maths and computer science. We have to learn at least a bit of it, if not at least collaborate. This is for my teachers, Kashif, who has taught me AI, Dr. Dash, who actually encouraged me for this, and of course, the IISc Bangalore, where I have trained for this. I think this is authentic data, real world numbers. So let's take this forward and understand that we are a different breed. I'm sure IHL is also on the same way. They also want to do research, because we all agree on one point, that we cannot extrapolate data from the West for us. Thank you so much.